record the warm-ups.
Mostly because of
So, warm-up number 1. So, x plus 15 equals a times x plus 1 plus b times x minus 6. This is a relatively easy one, right? Because there's...
You had x minus 6 for a and x plus 1 for b above.
No, I did not switch it up. And that will mess some people up if they're not thinking, if they're just flying through this. When I multiply through, the x minus 6 is canceled. That leaves the x plus 1. The x plus 1's canceled. That leaves the x minus 6. So let's try x equals negative 1. So negative 14 equals a times 0 plus b times negative 7, which means b equals 2.
How is it negative 14? Wouldn't it be positive 14?
I mean, yes. Thank you. Thank you for catching me early, though, rather than finishing the problem and then being like, hey, wait a minute. So b is negative 2. McKenna, there's the answer to your question earlier about how do I know if it's plus or minus, right? Set it up as a plus. If it ends up being negative, so be it. Then let's let x equal 6. See if I can do this one right. 6 plus 15 is 21. 6 plus 1 is 7. 6 minus 6 is 0. That's why we picked the 6. So 0 is that out. A is 3. I'm not done yet. Right? Alex Trebek wants you to give your answer in the form of a question. So 3 over x minus 6 plus negative 2 over x plus 1. That would be the answer we're looking for. Therefore, you don't have to. Not to pick on McKenna, but she was concerned about the negative thing. So if you wrote it like this, that would be okay as well, but there's really no reason you don't have to do that.
Do you think we're going to have enough time to finish?
So it's block day, right? Yeah, you'll be fine. Questions on that one? And remember, there's sort of the two weird cases. Not weird cases. Extra things to think about. What do you do if there's a repeated factor? Yeah, you need another one over here. You need a repeated, but it'd be x plus 1 squared. And what do you do if there's a quadratic that doesn't factor? Right, you need an ax plus b in the numerator. By the way, if you couldn't factor this one, if you thought this one was unfactorable, like you can kind of see what happens. This is almost dumb, but so if you thought it was unfactorable, so you set it up as, okay, it's got to be just that one with bx plus c. It's like you didn't really learn anything. B would be 1, c would be 15, and you hadn't got anywhere. But that's how you would set it up if it wouldn't factor. I don't know if I should have even showed that, because that's not how that works. If you had a denominator that wouldn't factor, like x squared plus 9, then you would have bx plus c over it, or ax plus b, depending on where you are in your a's and b's. All right, a graphing one. Yeah, you don't have provided graph paper, so I'll leave it for you if you want to try to graph it on your own, or if you just want to answer the questions and figure you could get it from there. So I'll give you a couple minutes to do that. If you x equals 1 because it cancels there. If you plug it into the original, you're going to get 0 over 0, but that's why there's a hole there. So plug it into what's left. 2 over negative 2, which is negative 1. Total fluke that worked out that nice. Aslan, how about vertical asymptotes? X equals 3. Danny, y-intercept? 0, negative 1/3. I like that, because y-intercept, we set x equal to 0. Naomi, any x-intercepts? Negative 1, 0, because that's where the top is equal to 0, where the y is equal to 0. Zainab, are there any horizontal asymptotes? Y equals 1. Good. Because horizontal and slant asymptotes, that's what happens as x goes to infinity, which is when you can use the top no, bottom O equal co thing, as long as you know what you're doing. Michael, so your answer is easy, but it's a concept thing. What's the slant asymptote? There's not one. Make sure you answer all the questions, though, right? Don't leave it blank. If you leave it blank, I'm going to mark it wrong because I'll think you don't know what the slant asymptote is. So if it's no, say no. Okay, let's see if we can put all this on the graph. A hole at 1, negative 1. Vertical asymptote at x equals 3. See how wild this is because I made this one up this morning. Y-intercept at 0, negative 1/3. X-intercept at negative 1, 0. And then a horizontal asymptote at y equals 1. Okay, so tons of points on the left. I definitely don't need any points over there. Or any more points, I should say. What about on the right? Is it above or below? Above, and you have to have 1 point anyway, so I may as well plug in x equals 4 or 5 or whatever. But you do need 1 point over there to sort of at least get a little bit of accuracy. 4 plus 1 is 5. 4 minus 3 is 1. 1, 2, 3, 4, 5. Did you put it in the original? Either one will work. You still got 5, I assume.
Yeah.
You can put it in either one. It's usually easier to put it in the one that's been reduced, but you don't have to.
Are these kind of fractions always going to be like symmetrical?
You mean is their graph always going to be? Yeah, like catty corner kind of thing. I don't want to say yes to that. You can't say that for sure. And the reason is if you get a denominator that has a repeated root in it, then whatever's going on at x equals 2 they won't flip across x equals 2. Like, I don't know what else is going on, but they'll both be going up or they'll both be going down. It's that double root thing again. I can't say that for sure. But you'll have enough information that you'll be able to tell. And if you get stuck, like save this for the end if it comes to this. But right, you just start plotting points and trying to figure it out. Like, now if you try that, you may not have time, but save that for the end, kind of last minute. All right, last one on the warm-up. Oh, we're still good on time. What values of x, if any, satisfy the inequality? So this was what Dia referred to as the number line thing. And that is correct. What would you do first on this one? I want to make sure we get off on the right.
Get the 1 to the other side.
Yeah, move the 1 over. Because we don't really like comparing to 1. We'd rather compare to 0. So move the 1 over, common denominator, zeros of top, zeros of bottom, intervals, open circles and closed circles, all that stuff. Okay, move the 1 over, make it a common denominator. Careful with the negative signs. Test the intervals. Or interval, right? If you want to use the alternating rule, you really only need to test 1. So I'm going to check 0. So 0 plus 4 over 0 minus 3. That's negative less than 0. That's a true statement. So I will shade there. If I'm pressed for time, I'm just going to alternate and say, well, it won't work on the others. My answer is negative 4 to 3. And I would not include either one. Never include the bottom zeros. This one doesn't have an equal sign, so I wouldn't include the top.
Can you write it as negative 4 is less than 1?
Yes, be careful. On the quiz, remember, specified inequality notation versus interval notation. So if it doesn't specify, then it doesn't matter. But if it does specify, then obviously make sure you give the right format. Yeah, so that's fine. This would also be one where maybe you star it and you're like, maybe I want to come back and check 4 at the end of the test if I have time, just to make sure everything looks right. So I finish the test, I come back, 4 plus 4 is 8, 4 minus 3 is 1. Is that less than 0? No, which is what we thought. Again, you only have to test one interval, but a lot of times students want to test 2 just to, make sure they feel right about it.